Hello, welcome to Astronautics for Exploits. This is Dr. Anyoshola Ogundele. Microgrid, a propellant of the evolution of smart cities and future of energy management. The focus points of my presentation are as follows: Microgrids evolution, the need for microgrid, forms of microgrid, and solar and wind microgrid. Microgrids, a small-scale power grid with distributed resources and an important component of smart grid development, are revolutionizing the way energy resources are being managed and are being proposed to be the future of energy management. Microgrids are assumed to be originated by Thomas Edison, who constructed his first power plant in 1882. A microgrid, which when integrated with the main grid, can lead to the evolution of smart city, can operate in association with the major power grid and as a standalone. It is a smaller grid which can connect and disconnect from a central grid so as to enable it to operate in both island and grid-connected mode. Renewable microgrids provide renewable energy networks that make use of zero-emission energy sources instead of using fuel sources that aid air pollution. They help to reduce the effect of climate change. A microgrid, an integrated energy system, consists of multiple electrical loads that can operate as a single autonomous grid that can operate in parallel or independent, and that is islanded within a region of distinct geographic footprint. Various benefits offered by microgrids are stability, reliability, autonomy, flexibility, scalability, and efficiency. The microgrid advanced control technology enables the network to operate stably. Due to the incremental building of the microgrid system, the system can be easily expanded. Being highly reliable makes the system to be able to make use of diverse mixture of renewable and fossil fuel options. Microgrids, which are increasingly becoming attractive, aid autonomous operation of the generation, storage, and energy usage by the loads. Also, microgrids are highly reliable because the generation is placed very close to the users, and this reduces the possibility of electricity disruption along the path. There are different forms of microgrids, such as community microgrids, campus microgrids, commercial and industrial microgrids. The aim of campus microgrids is to aggregate existing on-site electricity generation to support multiple loads located in a tight geographical area where an owner can easily manage them. Commercial and industrial microgrids are being designed to provide circular economy near zero industrial processes. Microgrids evolution. A microgrid is an integrated energy system that consists of distributed energy resources with multiple electrical loads operating as a single autonomous grid, either in parallel or independent, islanded from the existing utility power grid. Microgrids support smaller loads, serve fewer consumers, and are deployed over smaller areas. The picture here shows a schematic of a microgrid with different connected energy sources. Microgrids and wide area grids have the same function within the power generation ecosystem, distributing electricity and the same constraints, perfectly matching generation and load at all time. According to the research findings, Thomas Edison was said to have introduced the first microgrid in 1882. Geographic footprint. Microgrid generation, storage, and usage are all contained within a distinct geographic footprint, while its energy is managed by a system of control independent from the main grid. Functionality microgrid. A functioning microgrid has the components such as the power source, power management system, energy storage system, electricity, consuming devices, and utility connection. The picture here shows illustration of the use of microgrid in a community. The microgrid energy source is often adjusted for the demands on the microgrid, such as the generating capacity desired, as well as other considerations. Solar power has been an increasingly popular energy source for remote microgrid providing energy access to rural areas. Recent price drops in photovoltaic solar power models have made the economics of solar-based microgrids more favorable. The picture here shows visual diagram of a microgrid and conventional utility power grid. The microgrid power management system handles the transfer of electrical power from the power source to the electricity consuming devices. The microgrid storage systems are essential to any microgrid because they allow the microgrid to balance the electrical and thereby make the electricity accessible when it is required by the user. Electricity consuming devices dictate the electrical loads placed on the microgrid. The picture here shows the solar settlement, a sustainable housing community project. The need for microgrid. Conventional power grid, which is also known as traditional power grid, is an interconnection of various elements of electric power system, such as alternators, transformers, transmission lines, and different types of electrical loads, developed for transmission of electric power from production points to the utilization points. Traditional power grid provides reliable power most of the time, but when natural disasters or security breaches threaten the grid, the ensuing blackouts can be catastrophic and costly. The picture here shows the movement of energy in a microgrid. The key benefits of microgrid are efficiency, reliability, flexibility, stability, scalability, and autonomy. Using microgrids, energy can be optimized around both economic and environmental factors. The picture here shows illustration of how solar microgrid work. Reliability is one of the need for microgrids. Placing generation near the consumer enhances electric reliability, since there is less chance for electricity flow to be disrupted along the path. The microgrid's ability to isolate from the grid during a power outage is one of its hallmark features and allows it to essentially operate autonomously in deploying internet generation sources to serve its host. The picture here shows illustration of a microgrid. System expansion does not need to follow any precise path in microgrid, since lead times are relatively short and systems build incrementally. They also tend to be technology neutral, meaning the system is able to tap the best generation sources from a diverse mix of renewable and fossil fuel options without limitation due to technology. The picture here shows the picture of microgrid. Stability is one of the needs for microgrids. Advanced control allows the entire network to operate in a stable manner, whether connected to the main grid or not. Scalability. Microgrids allow for small generation, storage, and load devices in a parallel and modular manner to scale up power production and consumption levels as needed. The picture here shows microgrid composition. Autonomy. Microgrids allow generation, storage, and loads to seamlessly operate in an autonomous fashion, balancing out electrical voltage and frequency issues through advancements in control. The ability of this system to isolate or separate the cell from the grid and operate independently has become increasingly attractive. The picture here shows strategic microgrids. Forms of microgrid. There are different forms of microgrid. And some of them are campus environment institutional microgrids, military microgrids, community microgrids, remote off-grid microgrids, and commercial and industrial microgrids. Basic components of microgrids is shown in this picture. Campus environment and institutional microgrids. The focus of campus microgrids is aggregating existing on-site generation so as to support multiple loads located in a tight geographical area where an owner can easily manage them. The military-based microgrids are being actively deployed with focus on both physical and the security for the facility in order to assure reliable power without relying on the microgrid. The picture here shows an Unbound University solar microgrid. Community microgrids can serve thousands of customers and support the penetration of local energy, electricity, heating and cooling. In a community microgrid, some houses may have some renewable sources that can supply their demand as well as that of their neighbors within the same community. The community microgrid have a centralized or several distributed energy storages. Such microgrids can be in the form of an AC and DC microgrid coupled together through a bidirectional power electronic converter. The picture here shows community microgrids that allow communities to keep the lights on for a limited time while separated from the electric grid. Remote off-grid microgrids are generally not designed or intended to connect to the macrogrid and instead operate in an island mode at all times because of economic issues or geographical position. An off-grid microgrid is built in areas that are far distant from many transmission and distribution infrastructure and have no connection to the utility grid. The picture here shows Vo's microgrid system, which combine rooftop wind turbines and solar arrays. Commercial and industrial microgrids is another example of microgrids. These types of microgrids are maturing quickly. However, the lack of well-known standards for these types of microgrids limits them globally. The main reasons for the installation of an industrial microgrid are power supply and its reliability. The picture here shows container microgrids using modular design and streamlined engineering. Industrial microgrids can be designed to supply circular economy, near zero emission industrial processes, and can integrate combined heat and power generation, being fed by both renewable sources and waste processing. Energy storage can be additionally used to optimize the operations of these subsystems. The picture here shows recent advances in smart grid. Solar and wind microgrids. A solar microgrid is a renewable energy system that acts independently of the main grid, although it can also integrate and interact with the main grid when it wishes. Both solar energy and solar microgrids are great for the environment as they both generate energy using solar power. The picture here shows a solar microgrid. Solar microgrids can remove themselves from the main grid in what is called islanding. This means that if there is an issue with one area of energy output, the whole grid need not be affected. Solar microgrids are extremely beneficial to communities that need reliable renewable energy sources. The picture here shows a solar grid microgrid system. Solar microgrids are beneficial to communities where people don't have access to electricity. Using a solar microgrid will result in greater stability for community power system due to its ability to isolate itself from the main grid, which can come under attack from natural disasters and an electrical fault. The picture here shows illustration of a solar microgrid. The main wind microgrids. The main advantages of adding small wind turbines for microgrids are an increase in renewable energy supply a reduction in the amount of backup power required from a diesel generator, and a reduction in the strain imposed on energy storage, thereby extending battery life. Although solar power for microgrid is efficient and large cost effective, it still cannot generate power during the hours of darkness. The picture here shows illustration of space-based solar power system. For more information, contact Astronautics for Exploit. You've been watching and listening to Microgrid, a propellant of the evolution of smart cities and future of energy management, presented by Dr. Ayeshola Ogundele. With the focus points, microgrid's evolution, the need for microgrid, forms of microgrid, and solar and wind microgrid. Thank you.